Okay. All right, we're on. Welcome to the session. We're getting a couple minutes late here. So good news, we have 2 speakers in this session instead of 3. So I'm Heather Van Cura. I work at Oracle, and I wanted to start it off by saying a few words in context before I bring up my colleague, Sandeep Agarwal. So the AI horizon requires a foundation from which we can ask and answer questions that haven't even been thought of yet. And Oracle is positioned to guide you as you establish a framework for each of your own companies in a world where the horizon is always shifting and shifting quickly.
Can you say there are seats? So there are seats at the front if somebody wants to sit.
Oh, yes. So I want to share 3 points with you. Oracle works with multiple cloud providers and LLMs, and we have 3 differentiating things when it comes to AI in our products. And that is data. First of all, Oracle uses enterprise data with multiple LLMs, large models as well as smaller models. And you have your choice. And sometimes smaller models can be better, especially if you're training them for a specific vertical use case. Secondly, Oracle AI spans our entire product stack. So you might have heard of some of our products before. We have all the way from the OS to the cloud infrastructure, which includes things like Linux, Java, databases, MySQL, as well as the Oracle database. And thirdly, choice and flexibility. So multiple cloud providers, you can use whichever cloud provider you choose so that you get a choice of not only your LLMs, but your cloud environment as well. And all of these things are standards and open source based. So we're going to share with you today some forward-looking statements. But who here has heard of MySQL, the open source database? And how many people are using it today? Perfect. So you might have started using it a long time ago. Did you know that this year we're celebrating 30 years of MySQL? And Oracle is the steward of MySQL. It continues to be #1. So it's the #1 open source database, popular database for those learning how to code, and also the most popular open source database according to DB Engines. But did you know that it also is good for things beyond just the small projects that you might have started out using MySQL for? Because I saw most of you raised your hand. Have you ever used it, but are you still using it today? Maybe not. But lots of enterprises are using it today, so it can be used whether you're a startup or a large-scale enterprise. I want to tell you a little bit about a solution that we're going to talk about today, and is the topic of this session. But first, I want to tell you the origin story of this project. So all of you probably have your own origin story of your company, but you may or may not know that HeatWave started as a project in Oracle Labs. So labs work as a little bit like a startup environment in that you're researching a problem and you're coming up with solutions, and then you find the right market fit, which in a labs environment, you're transferring it to the product unit. So HeatWave started in the labs as a research project for using AI and ML in Oracle products. And it was created to solve problems like supply chain management, drug discovery, and IoT, solving real-world customer problems. And Sandeep here was actually a member of that team. And as they did their research, what they found was that a lot of the data in the world is stored in a MySQL database. And so we went to apply these solutions with AI and machine learning. It was a natural fit to build this technology behind MySQL. So in the labs, MySQL HeatWave was born, and now it's a product, and it's available to use. And I'd like to turn it over to Sandeep, who's going to go into some of the more technical details and share a little bit more about the story.
Okay. Thank you, Heather. Okay, so a little bit about me. Like, I'm Sandeep. I joined, I believe, the HeatWave team almost 10 years ago in Oracle Labs, and then before that, I did my PhD at Duke. So I've been doing building like AI solutions at least for Oracle and now for Oracle customers or MySQL customers for a while now. So let me tell you a little bit about what we're going to talk about here. So first, I'm going to talk about why is this cool, right? So one of the things that we aim to do, and I'll talk about that, is we want to bring all of your data should not move. All the applications and everything should work on a single copy of the data. That's the idea behind HeatWave. The second thing is, of course, you can start building with it, but then as you go into a production scenario, as you add more customers, as you basically scale out, this should still be the same solution, still be easy to use. And of course, once you have all your data in one place, you can create some really, really cool applications. And I'll be giving examples of a few applications that we have built for our customers and to tell you what stuff can be done with it. Then, how is this developer friendly? And because this is MySQL. MySQL is one of the easiest things in the world to install and use. And that's something we have tried to do with HeatWave as well. And we'll talk about that. And then how can you get started with it? So, given this is a GenAI conference, let's start with GenAI, right? So building generative AI applications is not easy, right? Because I mean, I've talked to a few of you here. I've talked to hundreds of different customers as part of this team, right? Everyone has data somewhere. They have data in Object Store. They have data in Oracle. They have data in Aurora. They have data in RDS. They have data in so many different places. And then they have a use case. They're like, I want to run queries on this data. The data can, and then if it's object store data, it can be logs, it can be PDF files, it can be image files, it can be anything, right? And you just want to know, okay, is this particular word, is this, you just want to answer questions based on your data, right? So you have to create this entire pipeline, you have to extract metadata, you have to do all this parsing, you have to create custom solutions, PyPDF, some other solution for parsing Excel, some other solution for parsing HTML, pull all this together in a giant Python script, deploy it. Then you have so many other challenges with scaling and so on, right? And then finally, once you have your data in some queryable form, then comes GenAI. Like so far, it was just data cleaning, data parsing, right? With GenAI, then you want to, okay, I now want to ask queries. So I want to ask natural language queries, or do I need to ask SQL queries? Like what do I need to do? Then I need to figure out, okay, what embedding models are good? Which LLM can I use? This LLM, that LLM, what works, what doesn't work, and then do prompt engineering, figure it out, get results. Finally, eventually, you create, let's say, at the end of all this, a chatbot. And then you can't go production with it because it's a giant Python script. You can't go production with a giant Python script. Doesn't work. So this is what a lot of customers currently do. And this is what when you go to other conferences, you hear about all of these solutions. You want to, okay, machine learning, use this solution. Generative AI, use this solution. OLTP, use this solution. Analytics, use this solution. And then eventually, you create another solution to glue all of these solutions together. And then you have this giant data science team just struggling to figure out, okay, and then you're paying for all of this through the roof, right? So, and essentially, to build a simple solution, you need 6 separate cloud services at this point, right? It just is expensive, it just doesn't work. So this is what we are trying to solve with HeatWave. It's just one database service. At the end of the day, data goes into a database. Unstructured, structured, doesn't matter. Data goes into a database. It needs to be queryable. AI, machine learning, analytics, OLTP, everything. As soon as you update your data with let's say, an insert query or something, because that's what most production applications do, it should be queryable immediately. You should not have to write a script to copy your data or migrate your data from your OLTP database down to, let's say, object store, where maybe somebody can pull it and run basically essentially generative AI queries on it. Everything should be on one copy of data. That's what this is. Real-time analytics. I have, for example, I have logs coming in. Immediately logs become available. Immediately I'm querying those logs and figuring out what went wrong in those logs. And I'll talk about that example as well. Because it's a single service, we manage all of this. Your data stays in one place. And the other part is because this is built as an accelerator for MySQL, as part of MySQL, all existing MySQL tools and services built over the last 30 years, which a lot of people use, work with it. That's it. Like it should be simple to use. Okay? To just get started, right? Usually I was thinking like, should I do the demo now or at the end? Let me show you what we can build with this. Hey everyone, good morning. Let it play. So we just heard Wim talk about something very, very powerful, the HeatWave REST service. Together with our existing in-database generative AI and JavaScript capabilities, we now have all the tools for developers to create rich and secure applications very, very easily. So over here, we have a demo mobile application showcasing how a doctor would basically take notes for a patient. So this application has been created on top of MySQL, right? So the first view is like all the different notes that the doctor has recorded for a given patient for multiple visits, right? These notes are stored in a relational table in MySQL, and all you're getting here is a view over these notes. Now, the doctor would like to create a summary for a patient across their different visits. They can do this very easily by just calling a REST endpoint called summarize. Internally, we will take care of retrieving them. So here in this demo, we are just using REST as one of the interfaces, one of the most popular interfaces for applications. So we are just using a REST interface, but think of the way to see this as your data just stays in tables, and now you have all the rich capabilities on top of the data in real time. Notes from the table. These notes will basically then be summarized using our generative AI capabilities, and the summary will be sent back to the application as part of the REST response. So all the application is doing is just invoking a REST endpoint. And as you can see here, the summary is ready, and this summarizes all the previous notes we have that the doctor has recorded for the patient. Now, let's say the doctor wants to share this summary externally, maybe with an insurance provider. Now, because the summary includes PII, like the phone number for the patient, right? You can't share this directly. So to remove PII and get this summary formatted as an email, we call another REST endpoint. Internally, we automatically process and remove all the PII using our JavaScript capabilities and format the summary as an email using our generative AI capabilities. And this anonymized email is then returned back to the application as a REST response. So you just saw all the application is doing is invoking a REST endpoint and getting these powerful features as responses from REST, as you can see. So yeah, okay. As you can see here, because we have generative AI and everything running within the database right here, so it's able to directly access the most up-to-date data and essentially operate on it. The generative AI is just one example. There's a lot of other things you can do. You can query it, of course, using it. You can do join operators. You can do a lot of other SQL things, as well as you can do AI things, everything on top of the same copy of the data. And essentially, this allows you to get very rich applications. Now, let me go back to the talk. Okay, so we just talked about how this is a single service with that can essentially address your most important use cases. Now, let's go to a little bit more detail into technology, what's happening a little bit behind the scenes. So, as I said, HeatWave is built as an accelerator for MySQL. So it accelerates OLTP, it accelerates analytics, it accelerates AI, it accelerates machine learning. So because at the end of the day, this is a database, right? So security is paramount. So one of the things we decided to do was have our LLMs running inside the database. What this means is that you can, of course, we of course also support external model providers like Cohere, Llama, and so on, right? You can still use them with data in HeatWave. But we also have LLMs running in the database. So this again goes back to the thing, you do not want to move your data. So these LLMs are run inside HeatWave. Nothing goes out of the network. Nothing goes out of the security domain. So this is also very secure, these in-database LLMs. But of course, these LLMs are essentially, I would say, smaller variations or more specific variations of larger LLMs. So they are tailored for specific tasks like RAG. If you want to do search on your data in the object store or in the DB, these LLMs work really well. So even if you don't have GPUs, even if you're operating in a completely secure environment, a completely air-gapped environment, this would still work. And this is very secure. And of course, you have all these other capabilities. Like I'll talk about AutoML as well. We have machine learning capabilities. All these algorithms are running in the database, operating on that same copy of the data. So we talked about LLMs, right? There's another big part of generative AI called vector stores, right? We support native vector store creation and ingestion. What that means is that, let's say you have files. Let's say take some. Let's say you have Wikipedia HTML files sitting in object store. You just run one command called HeatWave load and give it a path to an object store thing. It will automatically take all the data. It can be PDF, HTML, TXT, Excel, PowerPoint, Word, everything. And we are adding more and more formats. It will automatically ingest all of it, parse it, embed it, create embeddings out of it, and store it as a database table. So all that data is now available for querying along with all your other OLTP, your other relational data. So now you can do joins with your unstructured data and your structured data and essentially have a unified view. This is a very powerful capability, allowing you to unify all your different data sources. And of course, another thing I didn't mention, HeatWave scales up to 8,000 cores, which is 512 nodes in a cluster. So we have run this on like hundreds of millions of documents, and all of this ingestion, with like more nodes, you can just keep on reducing your time more and more and more. That's why I meant you go to production, this scales for any workload you have. Again, as I said earlier, we support two types of LLMs, the in-database and of course large parameter LLMs. So it's up to you. If you want to use more powerful models and you're okay with your data like leaving the database, then of course you have that freedom too. But if you want everything to stay within one environment and you have some regulations or something, we don't allow you to take your data out, we have solutions for that too using this in-database LLMs. There's something unique that only HeatWave provides. Now, before generative AI, if somebody remembers, there was something called machine learning. I'm sure some people have heard of it, not many. So HeatWave supports machine learning algorithms out of the box. And I'll talk a little bit more about why machine learning is not dead. At least we have found some very interesting use cases where you can combine machine learning and generative AI to create amazing applications, and I'll talk about them too. And because HeatWave supports AutoML and generative AI in the database, you can actually create these applications without ever moving your data. And that's one unique thing you get with the solution. And of course, the AutoML solution in HeatWave, we have support for classification, regression, anomaly detection, forecasting, recommender systems, and whatever use case you have, we have an algorithm for it. And these are all running inside the database on your copy of data. You can go from 10,000 rows to 100 million rows or even more. We will train on that data. We will do inference on that data. We scale across the full spectrum. And of course, the data can be in the database or in object store, doesn't matter. We will work with it. Now, let's talk about these applications I keep talking about, right? Like, what are they? So this is what we like to call the machine learning generative AI synergy. So one example, and this is something we did for a recent customer of ours, they had a bunch of logs in object store. This was essentially almost terabytes of logs, right? And they were like, man, when something goes wrong, right? We find out after things go wrong, and then our operators have to spend essentially days going through all these logs, figuring out what went wrong. it's very time consuming. And the neat thing here is anomaly detection solved part of this problem almost 20, 30 years ago. You take log data is just text data, right? You take text data, apply standard text preprocessing techniques to it, right? TF-IDF, BERT, whatever you want, right? You get that data into the database using HeatWave. You apply anomaly detection to it. HeatWave anomaly detection, because it supports text as well, it supports any data type, right? That's supported by MySQL. So we can actually detect anomalies in textual data. So what we do is that we take all that data, terabytes of it, train an anomaly detection model on it, and then whenever new logs come in, we just do anomaly detection inference, right? Machine learning inference, not AI inference, we'll get to that. So then we figure out, okay, something went wrong. The anomaly detection model marks something is going wrong, and at that point, we take the last 100 lines of logs, the next 100 lines of logs or so, feed these 200 lines of logs to a generative AI LLM, and ask it to basically root cause the problem. So essentially, the operator now, we flag essentially anomalies to the operator. Of course, there are false positives and so on as well. But the operator now has a ready-made root cause available. Now imagine doing this without machine learning. You would be feeding terabytes of logs into a generative AI reasoning model and ask it to reason about all the logs and tell me where the problem is. So this is where you can use machine learning as a first pass filter to an LLM. That's the concept. And this is not just anomaly detection. This can be used across a wide variety of algorithms. And this allows you to essentially lower the cost of using the LLM. And it creates this really unique root cause analysis application. So the operators now, it's like the customer basically was able to reduce their operator usage, by a significant margin. Next, this was done for a bank, a pretty big bank. Banks, of course, have these things where they have to deal with money laundering all the time, right? And usually money laundering transactions have some sort of pattern in them. For example, this was something called mule transactions, where essentially a scammer or somebody does a lot of zero value transactions against the bank, or very small amount. So we trained an anomaly detection model on it, and then the anomaly detection model basically figured out, okay, these transactions, and banks have like billions of transactions coming in. You cannot do this with GenAI. You have a machine learning model looking at all the transactions, figuring out which transactions went wrong, and then feeding those transactions to a generative AI model, asking it to tell exactly what went wrong. That allows you to essentially gain a deeper insight into the prediction, or explain the prediction, as what the previous talk was talking about. So this is where you can leverage ML and GenAI together. Now, for the third use case, this was done for a food delivery company. Think of something like Uber Eats. So essentially, you have a chatbot. You are asking the chatbot, I'm vegetarian, so recommend me 3 vegetarian places. I would like to eat, and maybe something that contains tofu, right? So normally, what would you do? You would essentially, and let's say you have all these restaurant menus stored as PDFs, right? This is what most of these companies have. They have the menus stored in some place, and then you want to search across all these menus. Now, imagine if you were just doing this with a generative AI model, how many menus you would have to search across. And then let's say the LLM just recommends, okay, these 3 restaurants have basically dishes containing tofu, and I'm like, man, I don't even like these restaurants. What are you telling me? So the way to fix that is you have this technique called recommender systems, which most companies in the world at this point are using. You have, so the model has my profile, the restaurants I like, dishes I like. It has the restaurant's profile. You use the recommender system model to figure out, let's say, the top 100 restaurants I would be interested in. And you take the menus of those top 100 restaurants and feed it to the generative AI model and ask it to then recommend basically 3 vegetarian dishes from those. So now the application is sure that these are restaurants I like because they were recommended by the model, and there are dishes I like because they were based on the user query. So this is another example of where you can create personalized recommendations with this AutoML generative AI synergy. Okay, so at this point, does anybody have any questions? We don't have to do this at the end. If anybody has questions, we can ask them now. Yeah, please go ahead. So, okay, at the end, I will have a slide. So, you can, of course, start for free. We have an always free tier as well. But the cost can, like, you can scale from 1 node to 512 nodes, depending on the size of your data. And essentially, the cost also, like, it's not expensive. It's MySQL. So, essentially, I have people here who know the cost better than me because it changes almost like sometimes. So, I think Salil here can better answer that question later.
We offer the best price performance in the industry because you cannot just look at just price. You have to look at performance and price together. So we have metrics that shows that this is the system that offers best price performance by the factors of 10x. We can provide you more details. I mean,
Yeah.
I hope you're not looking for a specific number, because it depends on what you need, how many nodes you need for your environment, your use case, etc.
But we do scale from 1 terabyte to 10 petabytes or whatever data size you have. So that's perfectly fine. And okay, and again, we can talk after this and we can get you started if you're interested. But again, yeah, it scales very well with the price scales with the data size. I think that's what you're looking for. Now, another thing to mention is, as part of that single service, you get all of this machine learning algorithms, this LLMs, everything just comes for free. In database LLMs, by the way, there is no charge. You pay for HeatWave, you are not paying on a per token basis anymore. Now, the next thing is, this is developer friendly. And what do I mean by that? So as I said, HeatWave works with all existing MySQL tools. This includes MySQL Workbench, all the different MySQL connectors, the Python connector, Java connector, JavaScript connector, whatever, like there are so many MySQL connectors out there. It works with all of them. We also have a REST service, which we recently launched, which allows, essentially we are hosting a REST server in HeatWave. So any REST client can interact with HeatWave via just REST calls. You don't even need a SQL client anymore. So that works as well. We have a VS Code plugin as well. If most people nowadays use VS Code. So you can actually just get this plugin, and this has more integrations with HeatWave. And of course, you have sample notebooks available at this GitHub link, which you can just go and check out. Lastly, how can you get started, assuming you want to try it out? So first of all, I have we have a brain date at 3:30. If you're interested, just come and talk to us. And then we also have this always free HeatWave instance available in the cloud. So what this means is, this is of course, like, this is not designed to handle petabytes of data, like, but it is always free. So if you build something with this, you will never be charged for it. So this actually has LLMs as well, which you can just try out. This has machine learning, this has vector processing, this has basically OLTP, OLAP, everything. And it's available in all OCI accounts. So, and if you can scan this QR code, you can basically just get started for free. And of course, Oracle also offers, I think, $300 in crowd credits if you want to, like, try out a larger cluster. So that's available too. Okay, any other questions? I gave you back 10 minutes of your time.
Hello. So in one of your examples, you said that you had an auto ML recommendation system.
Yes.
How do you ensure that your model is sound? And also, does that mean, like, are we able to train our own models too?
Yes, exactly. So we don't ship any recommended system models. The idea is that the customers have data, right? And so we have training APIs. So internally, we support a lot of different algorithms and so on. So the input to the algorithms, of course, you need to give the interaction matrix, right? So user item rating and so on. So you train your model on your data and then inference. And of course, we can help you train the model as well. But it is trained on your data. We don't touch any of it.
Okay, thank you.
Sure. Anything else?
So you're actually mentioning about the RESTful API, right? So basically, like, is it part of the HeatWave application, or like, so when you're actually making a summarize call, like, so let's say, like, I want some recommendations, like, based on the patient data, like, so suggest me some medication which can be provided, like, So in that case, like, so how do we make those API calls? Like,
Yes, so okay. So I did go into a lot of details about the REST service, right? So the REST service is something we recently announced. So we have some out-of-the-box endpoints like we ship, like for example, training, predictions, generative AI inference, and so on. But we also have the capability where you can create your own REST endpoints by just defining essentially JavaScript functions, and then HeatWave will host them for you.
okay.
So you can just create whatever you want. Yeah.
What would you say is next in terms of, I guess, updates or improvements to HeatWave?
Interesting question. I know what's next. I'm wondering whether I can talk about it. I would say better LLMs. There's a lot more coming. It's earlier. I would defer this to a PM. But faster, better, everything. Sorry about that. Anything else?
Yeah. With the in-database LLMs, what kind of visibility do you get? And also, when it's making the queries, how is it handling context window problems?
Define context window problems.
Like, I'm trying to think of a good example. Like if it's a very broad query that requires the LLM to look at quite a lot of data, how is it doing that gracefully?
Okay. So the most recent models we added, which is the Llama 3.2 models, right? They have a 128K context window size. So that's the max they can go. If you go beyond that, we'll truncate. Because again, these LLMs are running in the database, right? So they have to be efficient. That's one catch there, right? If you are looking for like million width context windows, then you go to essentially external generative AI services. That's the idea. So we do truncate, right? And of course, as I said, you can always use additional solution before the LLM, right? To essentially create like a first pass filter and reduce the context size, which also saves you cost. Any other questions? Okay. As I said, I'll be in the breakout, I think the brain dead room. We have a 3:30 session. And if you have any questions, just come talk to me or Heather right here. Thank you.